So for this problem, what I'm going to ask you to do is try to find the resonance and then come back and watch the answer. So moving along, the resonance for this will be these three resonance structures. So I'll go into detail. So whenever you have a positive charge and a double bond, or the other thing is you don't see it here, but there's actually a lone pair. You need to draw that out and see that there's a lone pair there. So if you have a double bond, a lone pair, and a charge, usually the double bond or the lone pair will go to fix the charge. So for example here, why there's a lone pair is because there's no charge on the nitrogen, so it has to have a formal charge of 0, and therefore it will have a lone pair, making it a formal charge of 0. So once you do that, you can move the lone pair and make it a double bond. Once you make it a double bond, the plus charge goes away, but then a plus charge appears on the nitrogen. The other thing you can do is keep the lone pair on the nitrogen and then move this double bond right here. So move the double bond to this side. And so what happens is you actually get a plus charge on a different carbon. So this one is actually, sorry about that. This one is actually the lowest in energy because, and you would think that these two would be better structures because the plus charge is on a carbon rather than a nitrogen. But this one's actually the lowest in energy because it actually has full octets. So that's a key thing to remember, that octets beat formal charges. So even though something has a better formal charge, meaning that the charge is on a less electronegative atom, a octet will beat that, meaning an octet will be lower in energy or a better structure. So this is actually our lowest energy structure. So this might be hard to see, so I drew out all the carbons and nitrogens and stuff, so it's easier for you to see what I'm talking about. So here I have the lone pair, and so all I did was move this lone pair and make a double bond. So what does that do? Well, since we have a hydrogen, right, you can't see it here because that's implied, but let's calculate the formal charge right here, right? So carbon is a group 4 element, and so it'd be 4, right? So it'd be 1, 2, 3, 4 minus 3 would be 1, and that's why this carbon has a plus charge. So now if we move this lone pair and make a double bond, now it has 4, right? 1, 2, 3, 4, and now it has a charge of 0. However, nitrogen, since we just gave away its lone pair, nitrogen is a group 5 element, so 5 minus 1, 2, 3, 4. 5 minus 4 is 1, right? So it has a plus charge. So always remember that when you make a double bond or a lone pair or anything, whenever you change something, two things will usually change. The place where you're moving it will change, and the place where the electrons are leaving will change. So always remember that two things will change when you're moving a lone pair into a double bond or vice versa. So the last one, all I did was keep the lone pair on the nitrogen and then see how originally the double bond is right here, or for example in these two the double bond is on these two carbons. I move that double bond right here. Now like I said, if I move the double bond right here, the plus charge goes away, and then a plus charge appears on the carbon, right? Because carbon's supposed to have 4 bonds, but this one has only 3, therefore it has a plus charge. So the main thing to take away from this video is that octets beat a plus charge or charges, meaning even though the plus charge is on a less electronegative atom, all of these have full octets, because as you can see, this one's the lowest in energy, but everything has full octets. That's why this is the best structure. And then if you have lone pairs or double bonds, and especially charges, that's usually where how you're going to find your resonance structures. You're going to move your lone pairs, double bonds, towards the plus charge, wherever the plus charge is in your structure. So I hope that helped, and thanks for watching.